Hello, and welcome to another episode of It's Stupid, and I Hate It. We're going to be talking about synthetic division here and why you should always use long division. Okay, so let's go to a new board, and let's first give you a reminder of what synthetic division is. And both of these techniques, both synthetic division and long division, allow you to divide polynomials. So that's the general idea of what we're going to be talking about today. We're going to be talking about dividing polynomials. So let's say that I had something like, I'm just going to make one up here, 3x squared minus 7x plus 5 divided by, remember, fractions is division, divided by, I don't know, let's say x plus 4, okay? So what we're going to do is we're going to talk about how to do this by synthetic division first. I'll show you synthetic division, and then I will very quickly show you why it falls apart very easily and why you just shouldn't use it. Okay? So, to do this by synthetic division, I'll give a partition here and show you how to do it. You make this weird looking thing right here, and on the outside you take this, and this is one of the first things that I hate about synthetic division, is that you have to remember to change that to the opposite sign. So this actually needs to be a -4 out in front here. Then you take all the coefficients of the things up here and put them next to each other with like some space so that you kind of know that you're doing that. And then you put like a line underneath this and then you're able to do what they call synthetic division. You bring down the first number, you multiply these two numbers, and put that new number up here. So you do -4 times 3 is -12. And -7 plus -12 is -19. So you add them together and put that answer down here. Do the multiplication again here and put the answer up there. So negative times negative is positive. 4 times 19 is 4 times 10 plus 4 times 9. So that's 40 plus 36 is 76, and then you add those two numbers together, and you have 5 plus 76 gives you 81, and this tells you your answer in synthetic division. Because of that work, you can tell, you look at the degree of the numerator, you take it down by 1, so I take this 3 here, and it becomes the 3, and then I put an x to the first, or just an x there, and then plus that -19 here, and then you get a remainder as the last number, and that's what synthetic division gives you. Okay? Now I'm going to take the same problem. I'm going to have to write it down here so I can write it on a new board. We're doing 3x squared minus 7x plus 5 divided by x plus 4. By the way, the way I did that negative 4 times negative 19, I said negative times negative is positive. And then I did 4 times 10 and 4 times 9, and I did indeed add them together, and that's how I got 76, because 40 plus 36 is 76, okay? So you get this answer with synthetic division. Now let me show you how to do that same problem using long division. So we're doing 3x squared minus 7x plus 5 divided by x plus 4. And for long division, we're just going to write it as a long division problem, and I'm going to change this minus up here to plus negative. I always like to change minuses into plus negatives, so I know when I'm dealing with positives and negatives all the way through. And so you could do this by writing 3x squared plus negative 7x plus 5 divided by x plus 4. Okay? And this is the long division setup for this exact same problem. Now, the long division takes more thinking. But I am going to show you why synthetic division fails you and all the ways that it fails you, and why indeed doing this long division process, not only does it get easier as you practice it, but it doesn't fail you in any of the cases where synthetic division fails you. So that's part of my argument here. So the idea is I want to multiply this x by something so that I get that number right there. So if I did this x times 3x, that would get me the 3x squared, because 3x times x is 3x squared. And I like to line up everything. If I'm going to be using an x, I'm going to line it up over my x term. Okay? So I'm going to do the same idea. I'm going to multiply, but I'm going to distribute. Okay? So I'm going to multiply by both of those things there. So 3x times x is 3x squared. And the whole idea was to match those up. Plus 3x times 4 is 12x. Now remember how you did long division in elementary school. You had to subtract those, and subtraction with this thing here is subtracting that whole thing, and it should be fairly obvious, I hope, that this negative has to distribute to both of those. Okay? So let me show you what that looks like. If I say a negative is just going to have to distribute to everything down there, then that means I change the signs on both of them. And that will allow me to add them together, and then I'm doing the subtraction, because subtraction is just adding the opposite, adding the negative. Okay? So now here comes the part that my students who have had me before will remember, which is these two cancel. They better cancel. If they don't cancel, you did it wrong. You designed it so that those two would cancel. And then you just have to add these two together to figure out what it is that needs to come next. So you're doing negative 7x plus negative 12x, which is negative 19x. Then you go up to the top, you put a plus, you go to here, you take this part and you bring it down, just like you would in elementary level long division. So it comes down, it becomes plus 5 down there. And then you start that whole game over. So you ask yourself, what do I got to multiply this by to get that right there? And to multiply this x so that I get negative 19x, I need to multiply by negative 19, and I'll line that up with my other number without an x attached to it. And then again, I have to do the multiplication. So negative 19 times x, remember I'm going to take this, I'm going to distribute it to both of those, okay? And so negative 19 times x is negative 19x plus negative 19 times 4, that's positive, times negative is negative, and then 19 times 4 is like 4 times 10 plus 4 times 9, which is 40, plus 36, which is 76. And then you have to subtract, which means distributing a negative, which means changing the sign on both of the things at the bottom. So those, in this case, both become positive, and you get negative 19x plus x, which cancel. Those two better cancel. You designed it so that they would cancel. And then 5 plus 76 is 81. And you get a remainder of 81, and I'll write that, but I'm going to erase it here because there's a better way to write it than just remainder. You can write it as plus 81 over that quantity x plus 4, okay? And so we have our answer from long division right there. 3x plus negative 19, which you could change to minus 19, plus 81 over x plus 4, which gives you an answer that really, in the grand scheme of things, actually means more. So let me talk to you a little bit more about what synthetic can't do for you, and one of the reasons that I really dislike it. And it is the same reason, for those of you who have seen the other videos, it is the same reason that I really don't like all the other stuff that I've said are stupid and I hate them, is because synthetic division, like all the other ones, like completing the square, it tricks you into thinking you don't need the other supposedly more complicated one, okay? But let me show you. If I change that problem just a little bit, I don't remember what the exact problem was, but I'm going to make up a sort of new one here. If I change that problem to 3x squared minus 7x plus 4 divided by 3x plus 4. Now, how would you set up the synthetic division for that at all? Okay? Because synthetic division doesn't allow for a number there in the front. Synthetic division you can only do with an x plus something or an x minus something. To throw a number in front of that x, all of a sudden you are talking, I just can't do it. Now, that's not 100% true. There are ways to do it. You could factor the 3 out to the front and do weird stuff with it. But the setup, okay, would be, how do I put a number right there? What do I do with it? So this is where we really get into synthetic division starting to fail us. But I can do this just as easily with long division as I could before. Let me show you. 3x squared, let's call it plus negative 7x, plus 4, divided by, I didn't leave myself enough room here, Let me erase part of this, or all of this. It's divided by 3x plus 4, divided by 3x plus 4. So there's the problem that we're trying to do. So I need to multiply something by this to make that, and that'll just be x, right? 3x times x is 3x squared. So I'll put an x up here, and again, I'm going to distribute, and that'll get me what I need. So x times 3x is 3x squared, plus x times 4 is 4x. Change the signs, so I'm subtracting. So there was me changing the signs. I didn't bother to change the color this time. And add things together. These two cancel. They better cancel. You designed it so that they would cancel. And then negative 7x plus negative 4x is negative 11x plus 4, because you're bringing down the plus 4. Put a plus up here and start this whole game over. So now the question is, what do you got to multiply by 3x to make negative 11x? Okay, you're not going to have to use any x's. You're just going to have to use a number. But the question is, what is that number? So you could set up a little algebra problem here. 3 times the number has to equal negative 11. And you just divide by 3, and so that number has to be negative 11 over 3. Negative 11 over 3. So when I put this up here, it'll be negative 11 over 3. And that's the number that I need. And I need to distribute that number. Negative 11 over 3 times 3. X is negative 11x plus negative 11, so there's part of the work. Let me do some more work here. I want to do negative 11 over 3 times 4 now. And when you multiply fractions by things that are not fractions, you multiply by the top only, so we get negative 44 over 3. And what you don't really need to worry about is, what is that as a mixed number? What is that as a decimal? We're going to do a whole nother episode on It's Stupid and I Hate It, where I talk about not using decimals when it's not necessary. But, so here we go. We got negative 44 over 3. Now I have to subtract these, so change the signs. So I'm subtracting. Those two cancel. They better cancel. That's how I designed it. And then one more piece of side work here. That side work is I need to do 4 plus 44 over 3. I'm going to put that, I'm going to make it 4 over 1, and what I'm going to do is I'm going to multiply the 4 over 1 by 3 over 3, so I get common denominators, and then you add the numerators, the top numbers. So 4 times 3, that's 12. I'll just make a little note here that that's 12, so I need to do 12 plus 44, and what is that? 12 plus 44, well, 10 plus 44 would be 54, and 2 more would be 56 over 3. 56, a quick check, is not divisible by 3, so I'll just leave it that way. The way you check that is you do 5 plus 6, and if it doesn't add up to something divisible by 3, then it in itself is not divisible by 3. You might remember that little trick. And that gives me a remainder of 56 over 3, or plus 56 over 3 over 3x plus 4. So let me write the answer real clear here. The answer is x plus negative 11, which you might write as minus 11 over 3, plus 56 over 3 over 3x plus 4. and there's the answer. Now again, let me mention a couple of things. First of all, you could not have done this problem with the synthetic division that I showed earlier. Okay? It's just not possible unless you do a whole lot of extra work with it. Second, notice how I left the negative 11 over 3 and the 56 over 3 as improper fractions, so-called improper fractions. I left them like that on purpose. And the reason is because when you leave things purely as fractions, as opposed to changing them to mixed numbers, one of the things that it does is it allows you to work with them beyond just this answer, okay? I can take the answer that I have here and I can make it a part of a bigger problem with writing it the way that I have it written. If I start trying to write things as mixed numbers, I start running into issues right away, okay? So let me show you one more type of problem that you cannot do by synthetic division, but you can do with long division, and we'll go through it. Let's say, I'm going to make it a tiny bit simpler, but let's say I wanted to do x to the 4th plus 3x squared minus 2x plus 7 divided by a quadratic. Okay, let's say x squared minus 3x plus 4. Now, I'm going to say you can't do that by the synthetic division that I showed you. That doesn't mean you can't do this by synthetic division. There is a form of synthetic division called quadratic synthetic division, but it requires even more remembering little tricks to make it happen. I studied this as a graduate class. The first time I ever saw synthetic quadratic division was during a graduate level course. And it is ridiculous. Let me just say that. We are way better off just setting up our long division problem. And you're going to see that this really isn't going to be so bad. Okay? So x to the 4th plus 3x squared minus 2x, so I'm going to call that plus negative 2x, so I'm very clear that that's a negative, plus 7, divided by x squared minus 3x, so I'm going to call that plus negative 3x, plus 4. Now, this works the exact same way. You look at this front number, or this front term here, and you say, look at this one. What do I got to multiply this one by to make this one? And of course, oh, and I missed something here. I apologize. Notice that we are missing an x cubed term. There's no x to the 3rd there. So the way we're going to compensate for that is we're going to have a 0x to the 3rd. And that's going to fix that for us. I apologize for not being specific about that before. So anyways, to make x to the 4th, what do I have to multiply by x to the 2nd? To make x to the 4th, well, I have to multiply by another x to the 2nd. So I'm going to put my x to the 2nd above my x to the 2nd term, and then I have to do the distribution on all of this. So this is going to be x to the 4th plus a negative 3x cubed. That's why you need that placeholder of 0x to the 3rd so that you can line that up, by the way, plus negative 3x squared. Okay? And then, of course, I need to subtract these, so I need to change the sign on all of them. and add them together. And these two cancel. They better cancel. That's how you designed it. And then 0x cubed plus 3x cubed is 3x cubed, plus 3x squared plus another positive 3x squared is 6x squared. Bring down this plus negative 2x, put a plus, and we start the game over. Now, I need to make the 3x cubed right there. What do I multiply by this x squared to make that happen? Well, 3x will do the trick. So that's 3x cubed plus 3x times negative 3x is negative 9x squared, plus 3x times 4 is 12x, and change the signs so that I am subtracting throughout. These two cancel. They better cancel. That's how you designed it. 6x squared plus 9x squared is 15x squared, plus negative 2x plus negative 12x is negative 14x. Put a plus, bring down the plus 7, and start this game over. Now what do you have to do to make that through multiplication is just multiply by 15. So I'll distribute a 15. That'll be 15x squared plus 15 times negative 3 is let's see, that's a negative. First of all, positive times negative is negative. And then 3 times 15 is 3 times 10 plus 3 times 5, so that's 30 plus 15 is 45 plus 15 times 4 is 40 plus 20. 4 times 10 plus 5 times 10, 40 plus 20 is 60. Change the signs so that I am subtracting. These two cancel. They better cancel. That's how I designed it. And then we've got negative 14 plus 45 with an x next to it. That's 45 minus 14, which sounds to me like 31, so 31x, plus 7 plus negative 60 is a negative answer, and 60 minus 7 is 53. So I get a remainder of 31x plus negative 53, all of that over that x squared minus 3x plus 4, let's call it. And so then you have your answer at the top there. You have your answer right here. I hope that clarifies why that's so important. Oh, I made a mistake here, didn't I? Yes, I did. Oh, I am so sorry. I apologize, everybody. I think we're going to have to do that problem again. So the mistake I made, I'll point it out here, is I did x squared times 4, and I got and I wrote 3x squared instead of writing no, never mind. No. I did x squared times 4, and I wrote 3 instead of writing 4. So, yeah. So, I should go back and fix that. If I fix that, all of this is going to have to change. So, that's no big deal. We can do that. Now, normally, I wouldn't erase this, but I've run out of room here. And I will talk at some point about not erasing. But I ran out of room, so I'm just going to do this. So if you caught that, good for you, good for catching it. We had to have x squared up here, and we had x to the fourth, 3x, negative 3x cubed plus 4x squared, and then I had to change the sign on that. So we had 3x to the third plus negative 1x squared, or just negative x squared. Okay, and then I need to bring down the plus negative 2x, put a plus, start the game over. Now I need to make 3x cubed. I'm going to multiply by 3x to make that happen. So that'll be 3x cubed plus negative 9x squared plus 12x. Change the signs so that I am subtracting. Those two cancel. They better cancel. That's how I designed it. And then negative x squared plus 9x squared will give me 8x squared plus negative 2x plus negative 12x is negative 14x. Bring down the plus 7, put a plus. Start the game over. Now I need to make 8x squared. I'll multiply the x squared by 8 to make that happen. So 8x squared plus 8 times negative 3x is negative 24x plus 8 times 4 is 32. Change the signs so that I am subtracting. Those two cancel. They better cancel. That's how I designed it. And then negative 14 plus 24 is 10x. And 7 plus negative 32 is a negative answer with 32 minus 7, which to me sounds like 25. So the remainder comes out to 10x plus negative 25, or minus 25 if you will, over x squared plus negative 3x, or minus 3x plus 4. Okay. So there we go. There's the actual answer. You got to be real careful doing this. There are a lot of things going on, a lot of moving parts, and you got to double check and look through everything, because a tiny little mistake like that, look, all I did was not write the 4. I wrote a 3 instead, and it, of course, changed the answer quite drastically there in the last two pieces. So just be extremely mindful of that as you work through these problems. Okay? So that is long division, and why it's so much better than synthetic division, and why synthetic division is stupid and I hate it. Because, again, sure, I made a mistake doing this problem, but I couldn't have done this problem with synthetic division at all. Okay, I couldn't have even started it. At least making a mistake is something that I can go back through and fix. Not being able to start the problem at all is a totally different problem that you can't fix in any way, shape, or form. Okay? So that is long division and why it is so much better than synthetic division. Thank you for watching.